This is the second video on section 6.5, tangent planes to level surfaces. So here we want to find both the tangent plane and the normal line to the surface at the point where t is equal to 2. And we have f of xy is x e to the y plus xy. Now here's the problem though. Our theory in this section deals with a function of 3 variables, and we have a function of 2 variables. So how do we handle that? Z is equal to f of xy, that's a function of 2 variables. So what we do is we create a function of 3 variables. Capital F of xyz is f of xy minus z. Now we have a function of 3 variables. Now we can use the theory from the earlier video. And so we have f of xyz. We simply substitute the definition of fxy up here, down here. So we have fxy minus z. So I'm going to do what I did with the last example. I'm going to do the calculations that we need that are common to both parts A and B, and then we'll look at parts A and part B. So first of all, we have the gradient of f, and we have the partial derivative with respect to x, partial derivative with respect to y, the partial derivative with respect to z. We are given in the problem the point t is equal to 2, where x and y are both defined in terms of t. And so to find x, y, and z, we go back to these equations and we substitute. Since t is equal to 2, x is equal to 4. Here, t is equal to 2, so y is sine of 2 pi, which is 0. And z is defined to be f of xy, so z is f of 40, and little f, so lowercase f of 40 is equal to 4. So we use the value t equal to 2 to calculate x and y, then we use the values of x and y to calculate z. So the gradient of f at the point 4, 0, 4 is 1, 8, negative 1. So now we can answer parts A and B. What is part A? We want the equation of the tangent plane. So we want the equation of the plane that contains the point 4, 0, 4, contains the point 4, 0, 4, and has normal vector 1, 8, negative 1. So it contains the point 4, 0, 4, and it has a normal vector 1, 8, negative 1. For part B, we want the normal line. So we want the line that contains the point 4, 0, 4 in the direction of the vector 1, 8, negative 1. And I wrote this in terms of the vector equation, but again, it's fairly straightforward to see what the parametric equations would look like. So x would be 4 plus t, y would be 0 plus 8t, and z would be 4 minus t.